The benefits of modern crypto are more than just encrypting a file, offering integrity, meaning that the file hasn't been changed, authentication, meaning that we know who it's from, non-repudiation, meaning that the sender can't deny sending the message, and forward secrecy, meaning that if the key is compromised, it can only be used to decrypt a single session associated with that key. Let's take a deeper look into one aspect of authentication associated with public keys. In our previous public key diagram, since the public keys are out in the open, what's to stop an adversary from encrypting a file for Bob pretending to be Alice? Well, that's where we can utilize the concept of signing with our private key. In this case, Alice will encrypt with Bob's public key and sign with her private key. Once Bob obtains the encrypted message, he'll verify that the file has been signed by Alice using information associated with her public key and decrypt it with his own private key. We'll learn how something like signing is done with password hashing in our salting slide and get more into depth into this in our GPG module. So what technologies use public key crypto? Well, tons. SSH, or Secure Shell, is one, which is used to communicate with Unix and Unix-like shell accounts. Then we have the one that everybody should know, HTTPS, that is HTTP Secure. HTTPS uses the TLS protocol, which used to be SSL, but everyone still calls it SSL to confuse you. If we use a self-signed cert for a web server, a client using HTTPS to contact your site will be prompted by the browser, typically saying something to the effect that this cert can't be verified by the certificate authority. Would you like to accept this as a valid certificate? This is equivalent to Bob saying, Alice, is this really your public key? Now, there are different ways to handle this, but the common way is to use a certificate authority to validate ownership of the public key. CAs include Symantec, Thauti, and DigiCert, just to name a few, and we'll see how to do public key encryption without a certificate authority in our GPG module. So far, we've discussed components of some crypto systems, but talked little about cryptanalysis. If you remember, we described cryptanalysis as the process of breaking into a crypto system, and that it was both an art and a science. Looking into the art, Moxley Marlinspike gives some great examples on how to break crypto systems, specifically HTTPS. For the first attack, we'll look at the X509 standard. That defines the public key certificate. It's a mess and allows the injection of things that maybe shouldn't be there. For example, when you go to register your domain certificate with a CA, you state your domain and validate that you own the domain as well. And in many cases, it's validated automatically. It's the same for domains with extensive subdomains. The CA would approve something like this, bigbank.com representing your financial institution. But because the standard allows for a lot of different characters, we could also get the following domain approved. This \0 represents a null value, and if you were to click on a link like bigbank.com \0.superhacker42.com, some browsers would get rid of everything after the null and would only display bigbank.com. And it would be validated by the CA as a secure site. This is a great example of a way a phishing attack can be very effective. As an attacker could use this crazy subdomain and make his website look exactly like the bigbank.com website. The next attack is pretty simple. When a user types in a domain, they usually don't prefix it with HTTP or HTTPS. They just type in the domain, and once it resolves to the server, an HTTPS page is used. However, what if an attacker was on the same network and captured your request before it even hits the real server? The attacker could just push a regular HTTP page back to you, a page that was in the clear. Because you don't typically check that you're on an HTTPS page, the attacker can push you that HTTP page without the HTTPS, a page that looks the same as, say, bigbank.com. The only difference is that you won't see a green lock icon or whatever your browser does to indicate that you're on a secure web page. With people as busy as they are, it may be good in the future to have HTTPS everywhere, with the browser adequately alerting that you're not on a secure web page. For even more interesting attacks, search YouTube for Moxie Marlinspike DEF CON presentation.